Okay, we're talking about 4.2. This is a nice review of quadratic functions, factoring, and complex numbers. Your essential question: what are the properties, graphs, and techniques associated with quadratic functions? And I'm not going to do a whole bunch here. I'm going to try and make this super quick. So if you are still struggling with factoring and you don't have your factoring friends can be found under the Algebra 2 videos. So maybe I'll write a little note here, factoring friends. If you want these guys, you're going to go to Algebra 2. And it's a 5.2 video. I think it's day 1. Otherwise, we're just going to review basically everything that you've learned in the past besides factoring. I'm going to assume that you know how to factor. So quadratic functions look like parabolas. Sometimes they cross the x-axis twice, giving you 2 x-intercepts or 2 solutions. Sometimes they only touch the x-axis once, giving you 1 solution, usually or at the vertex. And then sometimes they never cross the x-axis at all, meaning that you would have some complex solutions involving imaginary numbers. So we have learned in the past 3 different forms. You may have your parent graphs. And in the past, we would have talked about standard form, vertex form, and intercept form. So I'm going to quickly go over these for you. Standard form is given to you as ax squared plus bx plus c. Your axis of symmetry in standard form can be found by setting x equal to negative b over 2a, which then means that your vertex can be found, if you don't want to turn this into vertex form, by basically plugging that into the equation, the original equation, and getting your y. So your vertex is at negative b over 2a, comma, f of negative b over 2a. Which I guess would be more clear if I'd called this maybe f of x. So, for example, if you have, I think up above here, we had h of x, right? That's our standard form one. That's this top one here. Well, they're all in standard form, but I'm going to use this one for standard form. So if I had x squared minus 4x plus 13, and I wanted to graph this without using my graphing calculator, then first I'd want to find my vertex. So my axis of symmetry would be found where I put negative b, well, b is negative 4, over 2 times a, which is 1, giving me 4 divided by 2, which is 2. So that's my x value of my vertex, and also the equation of my axis of symmetry. Plugging that back in, finding h of 2, I find that I get 2 squared minus 4 times 2 plus 13, which is a 9. So I know that my vertex is at 2, 9. And I can easily graph this. I know that that's either going to be my max or my min. I should realize that that's my min because a was positive. We'll go 3, 6, 9, 12. So 2, 9 is my vertex. And if I wanted to find any more exact points, I could use an input-output table. Maybe I'll do 0. Plugging 0 in, I'm just going to get 13, which is here. And then it's symmetrical along that axis of symmetry. So I'd also go 2 to the right and also have an output of 13. So my parabola would look something like this. Now, vertex form, you've already been given the vertex. So your vertex is within the equation. It's at HK. So once you have the vertex, then you can do exactly what we did here, where we found another point and knowing that it's reflected over that axis of symmetry. And then the last form is your intercept form. Using P and Q just arbitrarily there. So you have your x-intercepts at x equals P and x equals Q. Okay, so for example, let's use f of x there, because that one's the one that I can factor really easily. Looking for factors of c that will, c and a, basically, that will add or subtract to give me this middle term, -4. Factoring 5 to 5 and 1. And I'll set this equal to 0, because we're trying to find our x-intercept, so y is 0 at that time. So this is going to give us x minus 5, x plus 1. And when you set each of those equal to 0, you get x equals 5, x equals -1. That gives us our x-intercepts, and then we're going to have to plug or do some work with that to realize that, well, our vertex, or our axis of symmetry, is right in the middle of those two. Okay, so axis of symmetry is going to be then at the average, or right in the middle of these two x-intercepts. So I could do 5 plus -1. Let's see, I'll put x equals divided by 2. That's how we get the average. 4 divided by 2 equals 2. And then again, I've got that x value. I can plug it back in and figure out what my y value is. So you can see up here, f, our axis of symmetry, is at x equals 2, actually for all of these, and then it's going to be some negative output. And I'll let you toy around with that. So hopefully that was all just a really nice review. If not, if you need some extra help, let me know. Turning the page over and getting a highlighter. Again, I said, now a lot of these, there's a bunch of examples in your book. So you can go through the chapter or through this section and see a lot of examples if you don't remember this, but I feel like I've pretty much drilled a lot of this into you. So there's the quadratic formula. It's how you find your x-intercepts if something's in standard form, if a quadratic's in standard form and you can't factor it. Then coming down to imaginary and complex numbers. So remember, the imaginary unit I is equal to the square root of -1. Or you can think of it as I squared equaling -1. Same thing. So a complex number then has real and imaginary parts. The real part is the A, and the imaginary part is the part with the I. It's a real number times the imaginary. And then just recalling complex conjugates, basically exactly the same terms, opposite signs, so that you multiply the sum and the difference pattern. You don't get a middle term, no more I. You multiply those last two terms, you get an I squared, which really is -1. So these are complex conjugates. So here's an example where they use the quadratic formula. Here's the function up here. Use the quadratic formula to find the x-intercepts. Well, there's really no x-intercepts, right? Because my discriminant, if you remember, this portion underneath here is called the discriminant. And it determines whether or not this thing is going to have solutions. So if it's negative, you're not going to end up with any solutions. You're going to end up with H here, right? Where it never crosses the x-axis. Now, how do we handle that? Well, that's the same thing as a 36 times a -1. and the square root of a -1 is I. So really the solutions to this quadratic equation are 2 plus 3i and 2 minus 3i. Notice those are complex conjugates. Now I wouldn't be able to graph this in the real plane, but I could graph it in the imaginary plane. And if you remember, the imaginary plane has two axes, but they're not x and y, they are real and imaginary. All right, last thing we're going to go over is completing the square. So when we complete the square, the reason we would want to do this is to get our quadratic, maybe from standard form into vertex form. So that's what we're going to do. It's important that you always take your x squared term and the x term and you associate them or you group them. You're going to find half the coefficient of the x term and then or of x and square that. Then you add the result basically to the side. You're going to put it inside that group, but then you're going to have to subtract it because you can't add it twice to one side, or you can't add it once to one side and not undo that. And then we're going to write it as a square of a binomial plus a constant. Okay, and it's important that for this to work, the coefficient of x squared has to be 1. So we're going to do it with this problem. So the first thing I'm going to do is I'm going to set this equal to 0. Actually, no, I'm going to leave y there, sorry. I'm going to group my x squared and x term. Now, I'm looking at this and I'm saying, hey, there's a common factor of 5, and I need x squared to have a coefficient of 1. So I can factor out the 5, leaving me with x squared plus 7x. I'm going to leave a little space here. And on the outside, I'm going to have plus 17. Now, what I'm going to add here is 7 divided by 2 squared. So 7 divided by 2 is 3.5. So really, I'm adding 3.5 squared. Problem is, I need to get rid of this because I just added it to the side of the equation. So I have to balance that out by subtracting it. But it's really not 3.5 squared. It's really 3.5 squared times 5. So I'm going to subtract that 5 times 3.5 squared. Okay, so this can now be written as 5 times x plus 3.5 quantity squared. And if you don't believe me, go ahead and redistribute this and you'll see you get the exact same thing. Minus, and when you do this math right here, you get 44.25.